In task 1 of experiment 5, you prepared 5 solutions by mixing 5 milliliters of iron 3 plus solution and 5 milliliters of thiocyanate solution. To look for the initial concentration of iron 3 plus and thiocyanate solution, you need to use M1V1 equals M2V2. If you recall, you prepared 50 milliliters of 0.200 molar of iron 3 plus solution. Thus, you should put 0.200 molar for M1. You mixed 5 milliliters of iron 3 plus solution initially, so V1 would be 5 milliliters. You're looking for M2 after 2 solutions were mixed. And after 2 solutions were mixed, the total would be 10 milliliters because 5 milliliters of iron 3 plus solution and 5 milliliters of thiocyanate solutions were mixed. If you carry out the calculation, and so for M2, you will get the initial concentration of iron 3 plus, and it will be the same for all 5 solutions because you used 0.200 molar of iron 3 plus solution to prepare all 5. For thiocyanate, it will be a little bit more complicated because although you still mixed 5 milliliters of thiocyanate with 5 milliliters of iron 3 plus solution to prepare a final 10 milliliter solution, the initial concentration, or before you mixed thiocyanate with iron 3 plus, was different. There are actually 5 different concentrations: 0, 1.00 times 10 to the negative 4, and so on. Thus, M1 will be different for those 5 solutions. V1 will be the same because you took 5 milliliters and mixed with 5 milliliters of iron 3 plus solution to make a final 10 milliliter solution. You're solving for M2, and V2 would be 10 milliliters. So do the same calculations for thiocyanate as well. So for M2, and use the different M1 for 2, 3, 4, and 5, and so for M2. After you make the 5 solutions by mixing 5 milliliters of iron 3 plus and 5 milliliters of thiocyanate solutions, you have to test the absorbance by using a spectrophotometer. So this is the absorbance that you recorded from the spectrophotometer, and you will see a spectra for each solution, and whatever wavelength that you recorded between 400 and 800 nanometers will be the lambda max here. That will be the point of the spectrum that has the highest peak. Next, result from the graph: epsilon with a subscript lambda. So this is the molar absorptivity coefficient at a specific wavelength. If you recall the Beer-Lambert law, the absorbance at a specific wavelength equals epsilon at a specific wavelength times concentration times the path length of cuvette, which is always 1 centimeter. And if you want to solve for epsilon at a specific wavelength, then you have to divide both sides by concentration. We can just ignore the path length of the cuvette because it's simply 1 centimeter. So epsilon at a specific wavelength equals absorbance at a specific wavelength divided by the concentration. So you have to graph the absorbance versus the complex at the equilibrium, the concentration at equilibrium. So the y-axis will be the absorbance and the x-axis will be concentration. So if we go back, epsilon at a specific wavelength equals the absorbance at a specific wavelength divided by concentration. So it's simply y over x. So if you look at a linear graph and you do y over x, it's simply the slope. So make your graph, and the slope of the best fit line would be the epsilon at a specific wavelength. Okay, so you need to look for the equilibrium concentration of the complex made. So look at the ice table here. So we know that the reactants are the iron 3 plus and the thiocyanate, and will form this red-orange complex at equilibrium. So the initial concentration after you calculate M2 here, it will be 0.100 molar, and the initial concentration of thiocyanate will be different depending on which solution you are talking about. And initially there's no complex, so the change would be will depend on the limiting reagent, which in this case would be the thiocyanate because it has a lower concentration. So we're assuming that all the limiting reagents will be consumed. So minus 0.001 molar and also minus 0.001 molar for iron 3 plus because it's 1:1, and we'll plus 0.001 molar for the complex, and again the stoichiometry is 1:1:1. So you're left with most of the iron 3 plus, and theoretically thiocyanate will be totally consumed, and you will produce 0.001 molar of iron, the iron thiocyanate complex. So if you look at this number matches this number. So if you do the ice table for all 5 solutions, you'll find out that actually the equilibrium concentration of the complex will be the same as the initial concentration of the thiocyanate solution. So this number here, those two numbers should be the same, and those two numbers should be the same after you solve for M2, of course, and the same for 3, 4, and 5.